Hello all. Welcome to the OpenEBS Contributor Weekly Meeting. Today is 9th March. We have a lot on the agenda today. The agenda document is shared in the chat window. Basically split this session into two sections. One is a quick update on 0.5.3 and also talk about a few undocumented features that we already have working in 0.5.3 that might help with troubleshooting the OpenEBS setups. And then we will talk about a couple of things that are coming up in the 0.6. Right? So the first thing will be Amit describing how to make the storage pods or the OpenEBS storage pods schedule on a specific nodes in your Kubernetes cluster. This has been there from 0.5. So we'll try to get this into the documentation as soon as possible, but today we will just give a reference to the issue where the contents are available, followed by how we can use Stern as a way of collecting the logs. And then 0.5.3 release has a few more, actually a couple of more outstanding issues. We'll just briefly talk about that. And followed by what we are changing with 0.6 in terms of capturing the logs using EFK as one of the options. Followed by the node manager, earlier what we used to call as a node bot, the design of that one. With that, I will hand it over to Amit, sharing the screen and then.
Yeah, thanks, Karan. All right, so the topic of my discussion is about dedicating nodes to storage. We have been getting a lot of requests from the user community on how to do that, right? So this is what a typical user request we have seen. They would have some dedicated nodes which they would like to have only the volume controllers running on. Again, they would also like the other typical application workloads not to run on these nodes, right? So in other words, they want to have some nodes that are dedicated only for storage, for the storage pods, right? And because OpenEBS has got extensions to Kubernetes, runs on Kubernetes in form of pods, this is a easy thing to do. So all the user needs to do is follow the taints and tolerations policies of Kubernetes. So for this particular example, the user can go ahead and taint the nodes that they want to dedicate for storage. And once they do that, so that will be the step one. Once they do that, the step two would be to patch Maya API server. This is a component of OpenEBS, right? Which helps to provision OpenEBS volumes. In other words, the OpenEBS pods. So what the user needs to do is they need to patch this particular service, which is a Kubernetes deployment specs, and that particular service would have some policies that would tolerate the taints. These are the taints which was done or which was framed in the step one, right? All right. So if you see the step one, this particular code, the kubectl code, belongs to the step one, where the user can use kubectl to taint the nodes, right? So what we see is these are the two labels that the user is tainting or is labeling the nodes. Let's say this is a key and a value. Storage equals SSD. So here the storage is a kind of a key and SSD is kind of a value. And this is the effect, right? So it means that the node called kubeminion-01 is tainted with a key called storage and with a whose value is SSD, and the effect is no schedule. That means any pods which do not tolerate this taint cannot be scheduled on that node, right? Similarly, at the same time, the user has gone ahead and given another specification, another taint to that same node, which says storage equals SSD, and after that, the effect is no execute. This means none of the pods can be executed on the node called kubeminion-o1 if that pod doesn't tolerate the taint name being storage equals SSD, right? So this is the step one. Now we go ahead and look at the step two. Like we discussed, the step two was to patch the API service deployment to tolerate these taints, right? So we go to the next slide, where this is a Kubernetes deployment, and this deployment runs the component called OpenEBS component called Maya API Server. I have skipped the details of this entire spec. I have only kept what is bare minimum, what is the necessary things to show for this tolerations. And we go straight into the tolerations, and we see that in the tolerations, it forms this kind of structure where the YAML says key equals storage, operator colon, operator equals equal, value is SSD. That means storage equals SSD, and the effect is no schedule. That means this particular deployment tolerates the taint with the key storage, value SSD, and the effect no schedule. Okay. In other words, this particular deployment, right, will be able to schedule itself onto that node called kubeminion-o1, right? Okay. It just came out. At the same time, it had to put up another toleration, right? Another taint toleration, which says storage equals SSD, and then it has something called no execute, right? So this means it will go ahead. This means so there is a slight difference between no schedule and no execute. So schedule is a stuff that happens during the scheduling of pods, and no execute can happen after scheduling. For example, the pod got crashed and it tries to be evicted to some other node. That too has been tainted in our previous step. So only those pods which tolerate the taint of no execute can get into the particular node, right? Even during the course of running that pod. That means during the eviction and after eviction, when the scheduler tries to reschedule that pod onto a node, that particular pod which tolerates this taint can get executed on that node, right? Okay, so to have the further details, this is the issue that has got most of the details, like how things needs to be done, the exact command. These are the exact commands rather, but some of the things have been omitted for brevity here. The user can go into this particular issue for the time being and check out all the details. And we are soon to get this into the documentation as well, right? All right. So this ends my topic here. That is a dedicated notes to storage. If there is any question, perhaps we can take it, or we will move it to the next agenda.
Thanks, Amit. Just one quick question. So the spec example that you showed shows that the tolerations are added to the Maya API server deployment, which makes Maya API server get scheduled onto that specific node.
Right.
What will happen to the OpenEBS controller pod and replica pod?
Yeah, that's a good question. Yeah, so I have actually missed it out. That's in fact a very good question. All right. So what the question that Kiran asked is, we have showed in the slides, right? We have showed in the slides that the pod called Maya API server will tolerate that taint. This means this particular pod will be able to be scheduled on the tainted node. However, this doesn't imply that the volume pods, which the volume pods are the ones which gets provisioned by OpenEBS, right? Due to the PVC that gets raised in a Kubernetes environment. What about those pods? Definitely, those pods won't be scheduled in the in these nodes, right? To do that, what we need to do is in the same specifications, right? These things needs to be enabled, right? Okay. Yeah. In fact, I actually forgot to load this particular thing. So if you see, if you scroll up, you see that this is same thing I'm talking of, the same deployment I have been talking of. There's a MyAPI server, which is of kind deployment. And till now, we were talking about these tolerations, right? If you scroll down further, there is something called environment properties, and we have to set these environment properties. So when I say there are kind of two environment properties, right? One belongs to the controller, the other one belongs to the replica. Controller here implies OpenEBS volume controller. Replica here implies OpenEBS volume replica. These are nothing but pods which gets deployed. And with this name, with this particular environment variable name, we can set up the value. The value will be k equals to v colon no schedule. This, in other words, means the node would have been tainted with a key called k and a value called v, and with an effect called no schedule, as well as the node would have been tainted with a key called rk and a value called rv with an effect called no schedule. So these are I mean, one can make out this is another form of providing these tolerations. If one is able to provide these tolerations, then the controller pod, or if you look at the second environment variable, the replica pod will get scheduled on that tainted node. Right? Is that clear, Kiran?
Yes, thank you, Amit.
Okay. Yeah. I'm extremely sorry that I could not put this particular thing. Rather, this was a thing that should have been put.
Thank you. This helps. I think the link to the issue also is helpful.
Yeah. This is that link 600. Yeah.
Any other questions, or we can move on to the next item? We can share the screen from Karthik's.
Hi everyone. So the next item we are going to discuss is about the OpenEBS logger. So just to give a brief background about why we need something called as an OpenEBS logger and what it is, etc. So we have seen of late that the users are grappling with some of the issues wherein the application is either in a crash loop back-off state, or the PV is not created, or it is in a read-only state, etc. And most of the times we are having to ask the user for a lot of the commands that we need, command outputs that we need from the cluster in order to get to the root of the issue. Just to aid the users with troubleshooting aspects, we thought we'll come up with a logging framework, something that is not exhaustive, but something that is ubiquitous and easy to get the required logs for the issues. Now, one of the, you would have heard Kiran talking about EFK in the beginning of this session when he spoke about the agenda. We'll also probably have a presentation about it, which might already be used by some of the users. Some of the clusters may already have a logging framework. Elasticsearch, Fluentd, Kibana kind of framework may already be available, in which case the logs can be just retrieved and provided. But in case that such an elaborate framework is not already available, then this is going to be pretty helpful. So we have named this as OpenEBS logger, and essentially it is just a Kubernetes job which can be run on the cluster to extract the pod logs and the basic cluster information. So when we say pod logs, it is in the control of the user to give what pods for which we need the logs. We can give regex with the starting literals of the pod names, and the tool will get the pod logs for that particular pods. It runs a container called as OpenEBS logger, and internally it uses something called as Stern. There is a tool that is popular called as Stern, which collects the logs of all the pods, and these are logs that are printed to the std out on the pods. So if there are logs that are not printed to std out or pushed into separate log files, at present the logger job is not capable of retrieving those, but that is something we will add to look we will look to add as future requirements. But for now it is able to collect all the logs that is printed out onto the std out, and it uses some kubectl commands to extract the cluster info. So generally in the OpenEBS issues, when you try to raise, you will see a default template which asks you for the command outputs of certain Kubernetes commands. So we've just used that set here, and it is just going to execute those commands and obtain all the information and bundle it. So what are the prerequisites to run this logger? There is a kubeconfig file that we need, and which needs to be passed to Stern. So typically Stern, from a use case point of view, it is run on the master. But since we are now running it as a Kubernetes job, the pod of this job can be launched anywhere on the node, and therefore we need the kubeconfig to be passed. We are creating a kubeconfig as a config map, and we are passing it to this pod. So that is one of the prerequisites. And the other prerequisites, which is not listed here, but we just spoke about, is to know that the particular log, error log, what you have is something that is getting printed onto the std out. So while this is going to be useful for getting information of the OpenEBS PVC pods and the operator pods, it can be used for any other application as well. So how do we run this? I'll just do a small demo, which is going to basically do these steps. Before that, just spend a couple of minutes on as an overview of how we are going to run it. So there is a logger script that gets executed inside the logger container, and we are passing the duration for which we want to log and a comma separated list of the starting literals of the pod names. So this regex is understood by Stern, and it gets the logs for all the pods which are beginning with these names. So the duration is something that you will arrive at depending upon how frequently or how much time it takes for an issue to be reproduced. Of course, we can keep running this job every time as something that we can bundle with OpenEBS, and it can be run for as long as the pods are running. That is also possible. But the more popular, or probably the more useful thing would be if you're already seeing some problem wherein your node is, your pod is getting into a certain state after about this much time, then you can give that as the duration time in the logger. So we are going to apply the job, and it will run for the duration that we have specified, and it will place all the logs, the output of the kubectl commands as well as the pod logs, into a log bundle. It is basically a tarball. So we are actually placing it on the node in which this debug pod is getting scheduled. So let's say you have a 2-node Kubernetes cluster, and you are applying this job, and the pod gets scheduled on node 1. So all the information of the cluster, whatever is captured by this logger, is placed in the /mnt of that particular node, and this is being passed as a host path. I'll just show you the YAML in a bit, but any other directory can be mounted as well. So here is the YAML which we are going to execute. We are naming it as the debug job. It uses OpenEBS logger container, and this is the command that it is going to execute. We are passing the kubeconfig as a config map. We are using root admin.conf is where we are mounting this config map. So we can create a config map like this. Typically, the kubeconfig on most of the clusters are either found in the etc kubernetes admin.conf, or it can be found in the home.cube/config. So this is where generally we get it from. If you're like unable to identify where it is, and if it is not in any of these locations, you can probably do a listing of the environment variables on the master, and that should help you understand where the path of the kubeconfig file is. And in the end, we are mounting the /mnt as host path directory to the spot, and logs are placed in a bundle like this, log/timestamp.tar. So let me go to the setup and execute what we just spoke. So I have a Kubernetes 2-node Kubernetes cluster, which is running version 1.8.2. I'm using ES6 VMs for creating Kubernetes cluster, and I used kubeadm to configure it. I have already deployed a Percona application. You can see it is running. OpenEBS operator pods are running. MyIPS server and OpenEBS provisioner. And in a Percona deployment that use the OpenEBS PVs are also running. We have the PVC controller and a single replica. So these are the pods that are running. And I would want to typically get the logs of the operator as well as the volume pods. So before doing that, we said the first step is to create the config map. So let me create the config map. In my case, I have placed the kubeconfig in the home admin.conf. So I'm going to use this to create config map. Name it as kubeconfig. Excuse me. So the config map is created. Let me just see if it is created successfully. Okay, it has been created. I have already obtained the debug job.yaml, which I have got from the test storage repo. So this log and the containers for information are placed in a repo called as OpenEBS test storage. So this is a repo that we are maintaining to hold all the test containers and any container that we are going to use, any custom container that we are going to use as part of the either the CI or for debug or for these kind of purposes. So logger is available here. You can find the Docker file and other details and steps to run. And the script that we are running here, all are placed here. I have obtained the debug job.yaml from here and placed it. I'm going to, let's say, also get the details of, I have the option of actually adding Percona also here. Let me add it. So this will give me all the logs, including the application logs, and reduce the duration. To a smaller value, just for sake of time. And I'm going to, as I showed you, we are going to get the logs in the mount directory. So the container has already started. We'll identify where the container is running. So it is running on Maya host 1. So I can expect my logs to be placed here. So it has already captured the kubectl cluster info. It's basically just a set of command outputs, such as what are the nodes and what are the pods running to the services and what are the storage classes, what are the PVs, and what are the persistent volume claims and to what they're bound, etc. You can get information of the other pod logs as well. I don't have any active IO or any activity running on these for now. So it gets logs, whatever has been logged till now, till this point. You might not see any logs that are available newly. So while this is going on, let me also, okay, you can see that there are the other logs for Maya and PVC and OpenEBS. If you see the pvc.log, you're going to see the logs for both replicas and controller here in the same log. So this is something that is configurable. We can split this by container using stern itself. That is one of the items that I would like to show as part of a to-do list that we have constructed. So it just completed the logs. Yeah, the job finished for 2 minutes, and it has taken all the logs and placed it into a tar file now. The user can just use this support bundle to sort of provide it to the team that is debugging the issue for quick analysis. Some of the to-do items that are there here are, it is currently, as you would have noticed, getting the pod logs and some kubectl info about the cluster. But we are also generally interested in the systemd logs on the application node, where we are seeing problems, typically the kubelet logs. So this is something that we have to also get as part of this container. So that is one of the items that is planned. So the stern has a lot of other flags. For example, we can also get information about, now you saw the logs, pods being deployed into default namespace, and we got the logs from there, but we can get this from other namespaces as well, depending upon where we have launched, what namespace we have launched the OpenEBS into, and where the application has been launched. Sometimes we might also be interested in the logs from the kube system. So we can get the pod logs of kube system as well by passing the namespaces. So when you add more and more flags to stern and make it more customizable, it is beneficial to add a config map for stern itself, just like how we created kube config and mapped it. We might need a JSON file or some YAML, which will basically have all these stern flags and the relevant values for that created with defaults. So that is something that we need to explore and add. And I just showed you the PVC log, and let us say there are more than one application. You have the PVC in the way that we just ran it now. You are going to have the PVC logs for more than one application bundled into the same log. While that is still okay, they're not having them at all. It is going to be a readability issue. There are too many PVCs. So we need to be able to map the application to the PVC and accordingly create our bundles. And also have the replica and controller log separated out. So stern is capable of providing this functionality. We have to use it and add that. So what happens when there are logs which are not on the std out and which are being pushed into some other log files, especially say in the case of the OpenEBS volumes. Let's say there are some other log files, or let's say for some applications there are some log files. For example, Grafana or Percona might have their own log files being pushed somewhere, which we might want to get. So this is something that can be included into the stern config map and which can also be extracted. So we have to see if that's something that is feasible via stern. So that is one of the things. And the color coding, of course, we all love color codes on our logs. So stern by default provides this. If you do not redirect it to a log file like we just did, we have pushed all the pod logs into the respective log files. If we had not done that, then stern would probably, when you do of the stern container itself, we would have seen the color coded logs, but it doesn't provide it when we push it into a log file. So if there is something that we can do about it, then that's something that we will be interested in as well. So these are some simple things that came up as feedback when we were discussing the stern pod, and the debug pod and what all we can do to enhance it. User feedback is welcome. Please do try it if you find that you have an issue and if you do not already have any logging framework available. So yeah, that's it from me. Do we have any questions?
Yeah. Hi, Karthik. Amit here. Karthik, does Stern...
any questions? We can move on to the next item.
Okay. Karthik, are you able to hear me?
Hi, Nishanta.
Yes, sir. Hello. Amit, go ahead with the question.
Yeah. So, Karthik, my question was, do you see it will be good to have to pass only the application name and the name and the namespace of the application, and let the logger do the job of collecting the PVC, PV, and whatnot, and get the required stuff printed out in the logs?
Amit, yeah, that sounds like a good item. I think we can add that as one of the to-do items for the Stern.
That's right. Okay. Okay. So, all right, Kiran, I had a second question. The second question was like, does it understand the patterns? For example, there'll be a couple of pods which will be outputting in different patterns, like log format patterns. Does Stern understand different patterns? Let's say, for example, the controller, the volume controller will be outputting in a particular format, and we would like the Stern to understand that format and pick up particular data. At the same time, there'll be other pod, for example, the replica pod, which will be outputting in a different format, and we would like to put that format to get out that specific data.
Right, got it. I think looks like that's going to be useful when there's like a flood of logs and we are probably interested only in certain patterns.
Right.
And also reduce the amount of the size of the log file. I don't know the answer right now, Amit, but I think this is also another good point to mention in the to-do items.
Right. Okay. So my last question was on the Docker tags. So we have not tagged anything. Do we think we should be tagging out that particular Stern image?
Yes, Amit. I think for now we just have it as a latest tag. So we can probably add a tag, version it based on what are the improvements we are making. Yeah.
Also, Amit, I think each of the items that are listed under the test storage come with their own Docker Hub repositories. So while Karthik was showing, that was another thing that I was contemplating, whether we should actually have this as multiple projects or have all of them still part of a parent project like test storage. We definitely need to come up with a better name there.
Right.
And each of them are not only helpful for OpenEBS, but this could be these are like general purpose things that could be used by any project, right? Yeah, so that's up for discussion. If does anybody else have any opinions on that one on this call? All right, we will leave it at that. Any other questions, or we can actually look at the other option that we have for logging that we have parallelly been exploring.
Kiran?
Yeah.
Yeah, I have one question. When the pods get exited and let's say they are scheduled at some other place and some other nodes, so will it be possible for it to get the old logs also, even if that pod is exited? Like, so there will be a timer, right? In that, after how much time these logs will be collected. So is there a
Payas?
yes?
Yeah, so Stern is capable of capturing the logs of the restarted pods as well. But what
Okay, so
probably it will do, yeah, it'll append it to the logs that we already have. For example, in the pvc.log, let's say the volume controller or replica has restarted, it will put the
okay.
logs of the container which has restarted into the same file. It will append it there. But yes, it will. If you have given the duration in such a manner that the restart is not going to be observed within the period, then we may probably not get it. Then we might probably have to give the right duration or have it run along with the application always to get all the logs of the restarts.
No, like so when a pod gets exited, and so as far as I know that Kubernetes deletes that container and recreates it, right?
Yes.
So that those logs and all will be gone. See those from the time when it panicked to this time, all these logs will be gone.
No, yes, that is what I'm saying, Pais. So let us say your pod ran for 5 minutes, the controller pod, and then it panicked and then it restarted.
Okay.
So you have the logs for those 5 minutes, and whatever logs you get post the restart, they are just appended to this. The pod loses the logs, but it is already captured in the log file that you used for Stern.
Okay, Karthik. Yeah, I'm done, Kiran.
And probably like just worth mentioning, so this kubectl logs has one parameter called previous. Um, I know it's not directly related to the question that Payas asked, but if a particular pod is in a crashed loopback state and we want to know why that is getting into the crashed loopback, sometimes it might help to use the logs with the minus previous option.
Okay, Kiran, that helps.
Cool. Thank you, Karthik. This was wonderful. Let's switch to Utkarsh for explaining us about the EFK.
Hi everyone. Is it visible to all of you?
Oh, Utkarsh, I can't see the slides. It's showing blank.
One second.
Your voice is
Is it
not
visible?
Utkarsh.
Okay.
It's currently showing a green screen instead of a regular blue screen.
Those are the slides, maybe. How do you get a green screen? So
And we will be discussing about log collection. Every time the pod restarts, so as Pius mentioned that the logs gets lost. So what we can do, we can set up a EFK stack where it can where E stands for Elasticsearch, F stands for Fluentd, and K for Kibana. So this will Fluentd will collect all the logs and it will send it to Elasticsearch, where it will be stored in the form of shards, and then we can use Kibana UI to visualize the logs. Can you move to the next slide? Okay, so these are the application we are using, and this issue has been tracked in OpenEBS repository under issue number 173. And so this is what I mentioned the problem summary earlier. And so I am using 3-node cluster on bare metal with the Kubernetes version 1.8.2 to give the demo. Can you move to the next slide, Amit? So this is some introduction about Elasticsearch. It is a search engine that is responsible for storing the logs, and then we can query it. So it can be deployed as a deployment for storing the data. For storing the data, we are using empty directory, but you can use any persistent storage such as OpenEBS. And it is Elasticsearch is also multi-tenant. Next slide, please. So Fluentd is again a open source data collector which collect the logs from the /var/log/container directory from the Kubernetes, and from some other logs can also be collected using Fluentd. For that, we need to configure Fluentd for that, and we can configure it via Fluentd config map, where we will have some predefined plugins which we can use. Okay. So one more thing, can we go back? So in order to Fluentd to work, we need to set this beta.kubernetes.io forward Fluentd-ds-ready true in the kube.sh file, so that it can automatically so that the data could not be ignored by the daemon set. So it will be deployed as daemon set, so that it can collect the logs from all the nodes. Okay. Next slide. So Kibana is the simple Kibana is UI for discovering and visualizing the logs. So it also has some lot of plugins available for better visualization for Kubernetes, and it provides you matrix visualization, and based on location, based on the maps, and you can see the from where the requests are coming from. Globally you can see the logs and visualize it using these plugins. It can be deployed as deployment also, and it can be accessed on node IP and node port. We are using node port as type in the service, but you can use as per your preference. Next slide, please. So these are some problems and challenges with the Elasticsearch, and the first and foremost issue is scaling and managing Elasticsearch requires a lot of work. As I went through some of the slides, and they have mentioned that it is quite difficult to scale it because a lot of manual work has to be done. So there are basically two ways by which we can scale. One is we can add more disks to it, and another one is using shards. So we can add shards and collect the logs, so which is a very complex process. So that's why usually people go for people outsource the Elasticsearch logging, and they keep developing his own software, and logging will be done by some other third-party vendors. Okay, next slide, please. So now I'm going to demo this. Can you, Amit, can you stop sharing?
Okay, let's hope the demo gods are in our favor and you can share the screen.
Okay. So I have already configured. So is it visible to all of you?
In a very funny way.
So this is Kibana UI, if it is visible.
No.
I don't know why it is not visible to. Okay.
Are you extending
Probably this is some network issue or something else. I don't know. So
No problem, Utkarsh. I think
we can do it later.
Yeah, you laid out the problem statement very well. I think we'll use the next session to kind of demonstrate this. And what I really liked is there is a problem with respect to Elasticsearch scaling, and going forward, if we can see how OpenEBS can help this problem by having some kind of a volume policies that can help with the scaling of the backend storage for Elasticsearch, that will be really cool. Nice. So before we get on to like one item, right now we are almost there with respect to the 0.5.3 release, except for a couple of things. So one issue that we have found is there's a iSCSI compliance test that is failing. Pius has been looking into it almost day in and day out. Pius, do you want to share any updates on that one?
Yeah, hi. So the latest changes which we had made for the memory leak issue, which we were having in the GoTGT, Jiva is using GoTGT for iSCSI target. So as part of the memory fix, some issue has come up. A task is getting deleted, which the libiSCSI test suite is expecting to be with us. So I'm looking into that. This task was basically so as part of the memory leak fix, what we did. So the problem was that there was a list of tasks which was not getting freed after the execution. Now we are freeing that because of now. So the memory is pretty constant after the fix. But this compliance test is failing because of one task as part of that fix getting deleted. So I'm looking into that currently.
Thanks, Pius. So the other pending item is making sure that we have all the documents for troubleshooting, especially the common problems with PVC failing to provision OpenEBS volume and iSCSI. The iSCSI related details have already just been put in. The next step would be to whatever we talked about in this call about the node stickiness and the collection of the logs, as well as some information on how to debug a failed provisions, is something that's pending. All right. We'll quickly move on to the next design item. Uma, back to you.
Yes. Sharing the screen. Just adjusting a few other things. So let me just start out by saying it's going to be a quick overview, maybe 5 to 10 minutes. It may cross the 10 o'clock, but I'll try to be short. The idea is to discuss the current work and also the future work, which is probably coming in the next couple of months. What we think of the storage extensions that can be applied to Kubernetes itself. First, I think we are trying out as part of the OpenEBS design, and we can think of poking or asking the community if this is a general issue that all other non-OpenEBS installations could be using it. The extensions that we are proposing are around PV, persistent volume. So the idea is let's go and do a quick overview of PVC and PV, how they're used, who's creating what, and then I'll discuss what are the extensions that we are actually proposing and working on. And then as part of the extensions, there's a new module component being created, OpenEBS Disk Manager, also known as a node bot. Potentially, it could become a Kubernetes node disk manager. We'll just go through the architecture overview of that. So it's pretty simple, really, how Kubernetes has designed the persistent volume and persistent volume claim. It's an object to connect an application to a persistent storage. That's what persistent volume claim. And the claim is really asked by the DevOps developer, and DevOps admin is responsible for actually satisfying a persistent volume claim. So just to put it in a little more graphical way, a developer is responsible for creating an application YAML, and the developer expects a storage class to be available, predefined storage classes with various parameters, which we'll discuss in a minute. And the developer creates a PVC, a persistent volume claim, and inserts that into YAML file, and Kubelet will really invoke the necessary execution paths as defined in PVC. Okay. So who actually, for the developer, it seems that storage class is all what matters. You take a storage class and then you construct a PVC, and who defines that storage class? That's going to be a DevOps admin or a Kubernetes administrator. And how does the admin create a storage class? Either using a static provisioner or a dynamic provisioner. And there are some other optional parameters that are allowed by the storage class spec. You can just write whatever the optional parameters you need, and those are implemented, understood, and implemented, satisfied by the dynamic provisioner. That's usually the architecture that Kubernetes has been following, and OpenEBS also has been following the same spec. And into that optional parameters, we have introduced fields like replication, monitoring, on and off, all that kind of stuff. And the way dynamic provisioner has been used is mainly to target external storage vendors on how can we use an external storage by a given application which is being containerized. But there's no way right now to treat Kubernetes as a real hyperconvergence box as of today, because in a hyperconverged mode, you need to be managing the disks that are attached to the Kubernetes nodes. And we do not have Kubernetes constructs today to represent a disk and associated management around the disk. Right? It all stops at a persistent volume. And this is really stopping us in treating a Kubernetes deployment as a hyperconverged deployment. So the idea is, what if we have a generic disk constructs beyond the given persistent volume, and what are the possibilities that we can do? How can we really manage hyperconverged scenarios with the Kubernetes? Just to recap, what are the disks that we are talking about? It could be local disks, rotational disks, SSDs, and NVEs, all that type, and also SAN, ISCSI or FC, or NAS and FS shares, and also the cloud disk, GPD, EBS, Azure, or all the other cloud disks. So these are all coming as a way to be represented as a local disk. And when you say I'm going to manage the Kubernetes as a hyper-converged deployment, you need to be having a more common way to deal with these disks and pull them together, and then use them, and then manage them, right? So what we are proposing here is we're all going to take this various types of disks and then call them as disk objects or DOs. And the thinking is it gets managed by another generic interface called disk provisioner. And from disk objects, you can create a storage pool. It is done by pool provisioners. This is another interface that needs to be created. Typical pool provisioners that satisfy this interface are, OpenEBS Jiva, CStore, or it could be the regular, the default ext4, or the commonly available LVM OpenZFS, or the other open source storage projects like a Gluster or SAP. Right? So all these are going to follow the disk objects as well as a way to commonly deal with how do you create a pool from a given project or vendor. And then from these pools, you're going to create persistent volumes. And this is already known, and that's done by dynamic provisioners. Next is really about representing the proposed node disk manager or node bot in a detailed way. The disk objects are going to be provisioned, monitored, and discovered by the disk provisioners, and we're going to use the etcd to store this configuration, and metrics can also be collected on the fly, and then it could be going into the standard metric systems such as Prometheus. And once you have the disk objects, pool provisioners, which are also going to be part of the node disk manager, would be giving a way to pull them together, and then dynamic provisioners are going to hook in tandem with pool provisioners to create the persistent volumes. So with that, compared to the original flow and the new workflow, how it happens, we are really creating a new workflow for the DevOps admin to manage the underlying disks. That's the new thing. So a DevOps admin will now use the disk provisioners to create disk objects, and how he or she requests a disk object is using a disk object claim similar to PV to PVC. And once the disk object claim is created, disk object and provisioner, disk provisioner will create a disk object, and then it is really fed into a storage pool claim, which creates a storage pool. And with those storage pools, DevOps admin will create a catalog of storage classes for developers to use. And one of the main addition that we're adding into this storage class is this concept of pool. Right? So far, it's all about I need a volume with certain parameters, but now you're going to say I need a volume from a given pool, right? That's exactly where the pool, and then the underlying disks are going to be hooked in. And this is a new workflow for the DevOps admin, and nothing really changes for the developer. A developer still chooses the storage class. Of course, he or she needs to know what the storage classes are and which storage class to choose. That's an interaction that happens between admin and the developers. And then the dynamic provisioner is really going to invoke a PVC and a PVS created on a given storage pool. This also will hopefully integrate nicely into the Kubernetes new scheduler that takes volume topology into consideration. Just imagine a disk object having a property related to rack, or whatever the other latency parameters, so many things. So you can really control, and the DevOps admin can really control a storage class can have certain parameters, like even though you have SSDs, you can just say there are some faster, higher latencies versus lower latencies disk pools, and then be able to schedule a given volume, a persistent volume, the required target. So that's really it at a high level. We have already made a lot of progress on this. Let me show some of them. Detailed design of disk node manager is being proposed at this location. Some good, useful links for you guys to go and read. And similarly, there is a CLI to manage the disk manager called Nodebot CLI, and there's also a pool provisioner implementation, reference implementation using CStore. This is also in the works. So that's all I have right now. The idea is to introduce to all of you to the disk manager and the reason why it's being developed and what's the roadmap. Any questions?
Thank you, Mo. It was well put.